Alright, so let's talk about the current in a parallel circuit. So what is a parallel circuit? Parallel circuit means that the current has more than one pathway. So for example, if you look at this diagram, right, there's a battery with two resistors. But this two resistor is connected in parallel orientation, right? Okay, so when the current flows, it will flow like this. After that, when you reach this junction, right, the current will split into two because there are two pathways. Notice that, right? So the first pathway will be right here. After that, it will flow through the emitter 2. And the second pathway will be the second pathway, which is the A3. So after that, it will recombine at the particular junction again and go back home. So that is the meaning of parallel circuit. So how do we calculate the current in a parallel circuit? So for example, let's just say I have a total current of 4 ampere. So this A1, right, measures a total current of 4 ampere. Okay, so of course the 4 ampere is going to flow in the yellow region, and when you reach this junction right here, the current will split. Of course, for these two resistors, in the event that we have the same resistance, right? So for example, 1 ohm here, 1 ohm here. Since they are the same resistance, hence the same current will flow through. So the current will split equally, which is 2 ampere and 2 ampere here. After that, when you recombine at this particular junction, they will recombine and of course go back home at a current of 4 ampere. So that's how we determine the current. Okay, so of course the case number 2, which is the most likely case that we are given, will be two different resistors. So for example, let's just say I give you instead of 1 and 2, right, I give you maybe 1. Okay, I give you 1 ohm here and 2 ohm here. Okay, so the current, I'll set it as 4 ampere. Okay, maybe I just, for easy calculation, I set it at 3 ampere. Okay, so of course, now I flow in the conventional current, right? So conventional current flows out of the positive terminal and reaches junction. Okay, notice that we have the first resistor, which is 1 ohm, and the second resistance is 2 ohms, right? So the current would like to flow through the path of least resistance. Okay, so of course more current will flow through the very first path compared to the second path. Okay, so how much more and how much less? So of course let's do a bit of ratio. So since we know that the first resistor R1 and is to R2, right? So the first resistor is 1 is to 2. So the total units of this ratio will be 3 units. So these 3 units will represent the 3 ampere that this emitter calculated. So 3 units represents 3 ampere. Okay, so now we determine how much current is going to flow through the green path. For the green path wise, right, of course, since I want more, so you look at the ratio, the first and the second ratio. So I want to multiply by 2 units because this part will have 2 units of current flowing through, and the second path will be 1 unit only. So 3 ampere divided by 3 times 2 will give you the 2 ampere that we are interested in. And the second path will be only 1 ampere. So that's how we use the ratio to calculate your current in the respective branches. Okay, so of course, in parallel circuit, the current will be more difficult to calculate because it's like something like a potential difference in your series circuit. So they both add up will give you back your total current of 3 ampere right here. Okay, so that is the current in your parallel circuit.